This video is on frequency distributions. These are used for categorical data and for numerical discrete data. So first up, what is a frequency distribution table and why do we use them? Well, let's look at categorical data first of all. Imagine I collect a data set. Maybe it's the colour of the eyes of the girls in my class. So this is quite a long list, and it's probably not the most efficient way to actually display this information. So a frequency distribution table is a table that just takes note of how often each piece of data occurs. And it looks like this. On the top line of the table, I record the data point. So in this case, that's colour, and there's 3 of them, blue, brown and green. And on the bottom row, I record the frequency of each of those. Now, when I'm trying to do that in this case, I don't want to accidentally leave one out. So I'm going to do a quick tally as I go through my list, and that'll help me keep track of how often each occurs. So looking at blue first of all. Okay, so I'm looking at my list here. I've got a blue, I've got a blue, I've got another blue, another blue. My 5th blue, I draw as a bar across, and then 1, 2, 3 more blues. And I can use that then to note that my frequency for blue is 8. Pause the video and complete the rest of the table. And at the end, my table should look like this. It's worth making a note of the overall total number of data points and checking it against your totals for the frequency. So when I count up the number of data points in my data set here, there are 18 of them. And when I add up the values in my frequency table, they also total up to 18. And this, of course, is the number of data points, so this can be called n. A word on how we can label the different rows of our data, of our frequency distribution table. The top row we can call x. That just represents the variables of the things that we're measuring. And the bottom row can be called f. And f obviously here for frequency. Notice that we can get the 18 by adding up our f values. So if we think back to our notation from our mean calculations, we know that this symbol here means add up. If I add up my frequencies, I get 18. Summation f equals to 18. And just note there that summation f and n represent the same information. In this particular scenario, we were dealing with categorical data. And so since we're dealing with categorical data, if I wanted to go ahead and calculate an average for this information from my table, the only average available to me is the mode. It's easy to identify the mode once you have your table drawn. You simply look for the highest frequency. The highest frequency is 8. That means the mode must be blue. Remember, it's not possible to calculate median or mean for categorical data, so there's no need for me to do any further calculation. Here's another example of changing a regular data set into a frequency distribution table. This time I recorded the number of siblings of the different girls in my class. And I'm going to transfer this information from being just a regular list into a frequency table. So this time my table's 2 rows are going to be titled number of siblings and frequency. Take a moment to pause the video and complete this table yourself. So my frequency distribution table should look like this. Note I can just double check that my frequencies are correct by totting them up and getting summation f, and just checking that I have 18 pieces of data in my original data set, which I do. So for a table like this, where I'm dealing with numerical discrete data, it's possible for me to calculate mode, median and mean. And notice again, looking at the frequencies to identify mode, that 1 occurs 5 times and 2 occurs 5 times. So in this particular case, my data is what we call bimodal. And this just means that the data has 2 modes. I can calculate the median in a very similar way to what I would do for a regular list. So I first of all locate the median using n plus 1 over 2. Of course, don't forget n and summation f are the same thing. So in this case, I'm going to use 18 plus 1 over 2. And that leads me to the 9.5th piece of data. Don't forget now 9.5 isn't the median. You can see that 9 Nothing even close to 9 is actually recorded in my data set, so it couldn't be the middle of my data. Instead, I'm looking for the 9.5th piece of data, but there isn't a 9.5th piece of data. Instead, I'm going to find the 9th and the 10th and average them. So how can I do this from my frequency table? Well, I can see that in the first box here, that's my first piece of data. I'm going to keep a running total in the corners of the boxes. So my first piece of data is included so far. When I include the next box, the next column if you like, 1 and 5, I've now dealt with the first 6 pieces of data. Add on the next 5, this brings me up to the 11th piece of data. Add the 3, I've now covered the first 14 pieces of data. Add the 2, I've got 16, and finally add the last 2 and I have 18. So what this means is that I know the first piece of data is in here, the 2nd, 3rd, 4th, 5th, 6th they're in here, 7th, 8th, 9th, 10th, 11th are in here, 12th to 14th, 15th to 16th, and 17th and 18th are in the last one. So this helps me to figure out where my median would be then. So I need to find the 9th and 10th pieces of data. Well, they're going to be in this column here. They're both going to be 2s. So in this case, my median is going to be 2, which is the 9th piece of data, and 2, which is the 10th piece of data, over 2. So the median is 2. And finally, it's possible to calculate the mean for a table. So the formula for the mean for a table looks similar in some ways to the formula for a list, but there's a couple of differences. For a list, we write our mean formula as summation x over n, and for a table, we write it as summation fx over summation f. But now we already know that summation f on the bottom here means the same thing as n. Remember that from our table, the top row is the x and the bottom row is the f. So really now what we need to understand is what do we mean by summation fx? Well, summation fx means that you're going to take each f, each frequency, and multiply it by the x or the variable above it. So for example, I'm going to take 1 and multiply it by 0, 5, which is the frequency, and multiply it by 1, which is in the x row, 5 by 2, 3 by 3, 2 by 4, and 2 by 5. And then the summation here at the start means that I'm going to add all of those up. So that's what the top row of my calculation is going to look like. And then the bottom row is summation f. And that just means add up all my frequencies, all my f's. And then I simply evaluate this to get my overall solution. I can type this all in one go into my calculator. And in this case, my mean is 2 1/3 or 2.3 recurring. Just watch out for instructions and questions as to how they want you to present your answer or round off. You may also be required to find an unknown in a frequency distribution table. So in this example, we're given a table with the numbers 1 to 4, and we also have their frequencies 6, 7, x. So I don't know what the frequency of 3 is, and the frequency of 4 is 3. And I'm told an extra piece of information, which is that the mean of this table is 2.2, and I want to find x. So I note that they're giving me the mean. So straight away, I'm going to make a note of the mean formula, which is, of course, x bar equals summation fx over summation f. And then I'm going to do my best to calculate these two things, even though obviously there's going to be x's appearing in both. So pause the video for a second here and see, can you write down what you think summation fx should look like? So here it is in progress, and then when I tidy this up a little bit, I get 32 plus 3x. Now I'm going to evaluate summation f. So here's my calculation in progress, and when I simplify this, I get 16 plus x. So now I'm going to fill these along with my mean value into the formula for mean. So this is the equation that I'm going to work with then. And again, pause the video at this stage and see if you're able to calculate the value of x. So I'll start by bringing the 16 plus x over and multiplying by 2.2, which I then multiply out. And now I'm going to get the x's to one side and the numbers to the other. I've decided to bring the x's to the right here, but you could have brought them to the left if you'd like and said 2.2x minus 3x. This leads to 3.2 equals 0.8x, and then I'm simply going to bring the 0.8 across and divide. And this will give me a result of x equals 4. So this was the unknown frequency.